this special video which is tailored just on request of one of our viewers. So we will dive today deep into why designing chemical processes with inherent safety in mind is very crucial. But first, let's try to understand what inherent safety really means. Now imagine you are building a chemical plant. Now, when you design a chemical plant with inherent safety in mind, you are taking a different approach to prevent the accidents. So instead of just relying on safety controls like alarms or getting a protective gear, you design the plant itself so as to avoid dangerous situations from the very beginning. Now this means actually that you will use fewer hazardous materials and choose the processes that are less likely to cause the accidents. For example, you might pick the chemicals that are safer to handle or use the methods that don't create as much risk. So essentially, it's about building safety into the design of the plant so that the risks are minimized right from the beginning and you don't reach to the situation of any calamity. After knowing what inherent safer designs are or inherent safety is, the question arises to our mind, how can we achieve that? How can I get an inherent safer design for setting up my company or setting up my process, let's say? So in that case, inherently safer designs can be implemented following 4 simple principles. Number 1 is elimination of hazards, which means you have to think of that particular setup in which you can remove or avoid potential dangers altogether. Second is the hazard we are talking actually over here refers to the potential danger. So second is reducing consequences, means minimize the severity or the impact if in case hazard does occur. So the after effects or the consequences of hazards, how can you minimize them? That you have to keep in mind while designing a process. Third is likelihood of the hazard occurrence reduction, means lowering the likelihood, decrease the chances of hazard happening. Just try to avoid those hazards. Make a setup or design a setup or design a process in such a way that you consider all the factors during that design so that hazard does not happens. So reducing the likelihood of its happening. Fourth is protection and separation. Just in case, after considering all the factors, let's say if the mishap happens, so keep the people safe by shielding them from the hazards. So by applying these 4 principles, inherently safer designs actually aim to build safety into the design of the plants right from the beginning, right from the starting, so as to ensure a safer environment for everyone who is being involved. Understand all the above story with the help of a very simple example. Suppose you want to set up a pharmaceutical company which is developing, you aim to develop a new drug that actually requires a hydrogenous process to produce an intermediate compound. Now you know what is hydrogenation process. So hydrogenation in pharmaceutical applications, actually it uses a pressure of 60 psi, that is pounds per square inch. But actually the value of this pressure can vary depending upon the substance. Basically hydrogenation is a kind of a reaction in which hydrogen adsorbed on the metal catalyst and unsaturated liquid oil. What actually is done, the oil is mixed with the catalyst, usually we take nickel as a catalyst, and then it is heated to a temperature between 140 to 225 degrees centigrade and then exposed to hydrogen while being continuously stirred or moved. The mixture is then mechanically agitated at the desired pressure. So, and the desired pressure is usually 60 psi, which is mentioned. Now, this is the process that your company actually will be taking care of, and this will be the process which will be happening in big containers, not a small one. So, how to reduce the likelihood of accident in your company? The good practice is just design the reactor, the hydrogenation reactor, in such a way that it has proper pressure relief systems and controls to prevent over pressurization. This is the good practice that most of the companies do, and you will also in the first go think about this. Okay, let's design that kind of a reactor. But keeping in mind the inherent safety, what you can do? Select the catalyst and the operating conditions in such a way so that you can minimize the risk of unintended or undesired reactions or explosions. For example, you can use a catalyst that operates effectively at lower pressure so that you don't have to go for a higher pressure value, and the temperature actually reduces the likelihood of any mishap or hazard which might happen due to the high pressure. Second principle one of the principles that we discussed was mitigating potential consequences. That means how can you prevent those consequences? How can you reduce the likelihood of those hazards occurrences? Reduce the severity or the scale of those consequences of the hazard. So the good practice is you will install a hydrogen gas detecting system so that it can detect any leakage of the hydrogen gas if in case it happens, and the detector you will connect it to the control system, which actually if such a leakage of hydrogen is there, the emergency shutdown of the procedure is done. This is what actually you will think about, or any company thinks about, and some of the companies do have these practice. But if you work according to inherent safety, how will you go? What will your approach be? You will choose a process design that inherently minimize the consequences of the leakage of hydrogen or the release of hydrogen. Like for example, locating the reactor where you can keep the reactor in such a place which is very well ventilated, so that even if there is a minor leakage, then circulation of air in that particular area can overcome that. And secondly, you can use the materials which can withstand hydrogen exposure without degradation, so that your other setups, other systems are not affected. So just by picking two principles of inherently safer designs, you can change the entire scenario, entire process of the pharmaceutical manufacturing companies, and go into the environmental friendly methods or steps. This is actually what is meant by inherently safer designs. So I hope this satisfies your query well. Just stay intact, and please do ask questions so that we can have a discussion like this.